Okay, so obviously last time we finished with the debugging, and the last thing we talked about with debugging was the rubber duck strategy, which I know sounds like a joke, but it's not, it's a real thing. It doesn't have to be a rubber duck. You could talk to any inanimate object, but yeah, yes?
I ordered 12 rubber ducks.
There you go. Order 12 rubber ducks. 12's good because you can leave them laying around the house. You never know when you need a rubber duck. Put one in the shower, you never know. Put one right beside your bed, you never know, right? When in doubt, talk to the duck. So now we're going to move on to file I/O. I/O is input-output. At this stage, obviously I'm aware that, like in assignment 1, you had to input data, but I gave that function too, right? I gave you the function to load the Starbucks data, right? And it had file I/O there, file input specifically. But you know, you were required to read through it, try to get a sense of what's going on, but we never really learned it. And at this stage of the game, you're probably going to see the next couple of topics. Let's just say this one. This topic, you probably push come to shove. If I told you load a text file into Python, you are definitely equipped enough with the skills to go figure this out, but we're going to talk about it anyways, just to maybe hit some of the interesting things. At this point, we've seen how to get information into the computer. We used input. We saw that we obviously can manipulate data, play around with data in the computer. And we saw how to get output, just print. Sometimes we also like to think about like input output to like a specific function, but it's the same idea, right? The trouble is, if I have massive amounts of information like in assignment 1, because how many, did I give you 50,000 Starbucks locations? Something like that, right? Imagine I told you enter those in one at a time. No, that's a ridiculous thing to ask of you, right? You're going to load it all in one shot in a file, and the computer can do it like that. So file I/O is obviously really important if we want to import a lot of important information, and we want an automated way of doing it, because it's always really silly to just be like, okay, user, enter this and wait. It's kind of wasting a lot of time. So text files. Text files are going to be the simplest things that we can play around with. Now, interestingly enough, on your computers, you may notice that if I go, first of all, I'm going to make it just a regular text file here. I'm going to save it to my desktop because I'm going to use this in CoLab. So, hello. Right, so here we go. It's a file. I'm going to save it to my desktop called fun.txt, right? Now, interestingly enough, these little file extensions, where's fun.txt? Did I not just save it to my desktop? Where did I save it? Oh, okay, in my home folder. All right, so let's go here. There. And I'm just going to move to the desktop. There. Fun.txt, there it is. You can see it, it's there. Interestingly enough, the file extensions don't really matter. They're just like hints to your computer about what application it's going to be used because of the type of file it is. It's just a convention. If I go, I'm going to rename this to like definitely not txt, fun.definitely not txt. It doesn't matter. If I open this file with a text editor, it's still the text file. So just an interesting thing to note. Also, another thing to note, if you are using, I'm sure Mac probably does this too, I'm just more familiar with the Windows. If you are using a Windows computer, I believe by default it will, like your computer will hide common file extensions, like file format extensions. So like it's a like dot file. Microsoft won't show you that it's like assignment1 .doc. It'll just say assignment1 because you know what the file is. The trouble with that, and this would also be true for like .txt files, it would hide those file extensions. The trouble though is, even though it's hidden, it's still there. So you might be looking at a file on your desktop called the data, and it's only called the data, and then when you're trying to load it, you're saying, well, the file's called the data, but it's not. It's called the data.txt. So it might be hiding some stuff, and then sometimes people will be like, oh, it's missing the .txt. I'm going to go add the .txt to the thing on my desktop, so it'll be the data.txt. But the .txt is already there, so by renaming it, you've actually renamed it the data.txt.txt. It's a nightmare. Long story short, if you're on Windows, you may choose to turn that option off of how to, like, turn the option off on hiding common file extensions, because it ends up, it could bite you. Just FYI. All right, text files. Text files stores textual data, right? Here we go. Here's a file called fun.txt. All of your computers, you should be able to just make your own text file. We can put whatever we want in there. Right? That's it. Can I zoom in? All right, not easily. Now, this might be a very important file for our program. So we want to be able to read information from this file. Fortunately, in Python, it makes file I/O nice and easy relative to other programming languages. Some other programming languages make file I/O a little bit cumbersome and difficult, but Python does a good job at hiding a lot of the extra stuff that goes along with it. So because we're using Colab, the first thing I'm going to have to do is I'm going to go file, oh, here, I need to look at, there. I'm going to upload desktop fun.txt, there. Yeah, reminder. Okay, so I've just uploaded the file to Colab, so now Python can actually see it because it's there. And if I want, I can like just look at this. If I double click it, it'll show me what's in the text file, which is nice. So there, I've uploaded the text file to Colab, but now I want to read information from that text file. That's the problem we're currently facing. So how do we do it? Okay, reading from a text file. Here is the syntax that we file. I call my file called my file because it's just a variable name. So I'm going to open the file and store the file stuff in this variable. Even it's a reference, but we're going to have it by the variable name my file. And then to open a file, I just use this open function. And the first parameter in the open function is the name of the file I want to open. The next parameter is, and this convention's an old convention when it comes to like the second parameter here. This next parameter actually specifies the mode in which we are opening the file. Who wants to take a wild guess? I mean, if you look at this, what's on the screen, you'll know. Who wants to take a wild guess what R means? Read. How'd you know? You read it. Well, there you go. That's funny because read and read. Nice. So we open it in R mode, read mode. Who wants to take a wild guess if we put W there? Instead of an R, we put W. What do you think that would mean? It's a shot in the dark. I know you don't know. Right? Wow, you're right. How about that? Right. There's write mode. So you can read from a file, write from a file. There are other like modes you can set it to, but these are the ones we're going to care about right now. Now, this right here assumes that the file I'm looking to open exists in the current working directory. When using Colab, this is a very simple thing to deal with. The working directory is going to be like right here, right what we're looking at, all right? It's here. This is the working directory. But I could say like new folder and put this inside temp. And so the working directory is now, it's up here, but the file I want to open is in a folder called temp. So just to show you what we would do in this scenario, well, first let me show you what happens if it's not in the working directory. If I run this, it's going to say, no such file or directory, fun.txt. It's saying I can't find it. Well, and that's because it's not in the working directory. I put it in temp / it's in that folder / fun.txt. When I hit run, there, it's happy. Great. So there. I've uploaded my file to Colab, and now I've opened the file in Python. But I haven't done anything with the file yet. All it is I've got this variable that gets me to the file. But what do I want to do with this file? Well, I'm reading it, I'm opening it in read mode, so presumably I want to read from this file. So if I go down here, I'm going to do my file dot, and we're going to see a bunch of methods that we could use when playing around with the file. What do we see? Well, we've got some things there buffered. We have close, detach, file no, flush, is addy, new lines, read, readable, read line, read lines, reconfigure, seek, seekable, tell, truncate, writable, write. There's a bunch. A bunch of these we're not going to care about right now, but we can have a look. Writable, let's see. What does writable do? Writable, return whether object was open for writing. So this is a method that returns a Boolean, true or false. I open this file in read mode, so what do you think this would return if I called it? False. False. Let's just see what happens. Print. False. Okay. How about readable? What do you think this would be? All right, cool. Makes sense. So we can actually ask a file like, hey, can I read from you? Can I write from you? Write to you? So that's kind of neat. But there's a bunch of other things in there. We'll do this activity together. Create a text file somewhere on your computer, perhaps desktop. Well, I just did. Upload it to Colab, just did. Open your file in the above, like in the above example. Yep, just did. Now, try using the method readLine and read. So let's do that. So let's start with readLine. So here's my text file. Hello world, this is a text file. This is fun, nothing, woo, nothing. So if I were to say, read line, print. When I hit run, even though you've never seen this before, when I hit run, what do you think will get printed out? The first line, right? Is that what you were going to suggest? Well, let's just see. Yeah, there we go. Makes sense. I said, okay, my file, read a line. It goes and reads one whole line. It's smart enough to know when a line ends. I save that into a variable called the line, and then I immediately print it out. So there we go, great. Now, I'm going to go down here. My file.read. Now, when I hit run, I'm going to give you a moment to think about this one. When I hit run, what would you expect to see? I know you haven't seen this before, but make an educated, informed decision about what you would expect to see when I run that line of code. Now I'm going to hit run, and we're going to see the result. Does that make sense to you? Take a moment, look at it. I see some people nodding their head no. Raise your hand if you're like, yep, that makes perfect sense. I have no questions. Raise your hand if you're like, yeah, what? I got a problem here. Okay, let me guess. Your problem is, well, it skipped the first line. Is that where you're concerned? Is it just didn't print out the hello world part? What were you going to say back there?
No, yeah, that was fine.
All right, that's what you were going to say. So read means read the whole contents of the file, but seemingly here, it skipped the first line. But it doesn't, because we already read the first line. The file, when you read the file, and you read anything, it will go read, and then it remembers where it finished reading before. Let me show you what happens. I'm going to run this cell again. Nothing comes out. Because after we read the file knows, well, you read everything. So there's nothing more to read. So when I'm saying like read, it's like, no, I'm done. There's nothing more to read. Let me put it this way. I'm going to reopen the file. I'm just going to run this cell again to say reopen the file. Just start over. I hit read line. It reads one line and it remembers that it read that first line. I'm going to run this cell again, the read line cell. It already read hello world. So when I hit run again, it will read the following line, which is this is a text file. I run again. This is fun. I run again, I get nothing. I run again, I get woo. I run again, I get empty. And then there's nothing left. So the file is like this thing that when you ask to read to it, it keeps track of where it finished. So if you ask again, it knows where to keep up from. So let's say this is the file inside the computer, and it's got a bunch of information in it. Right? And when the file starts, it's going to remember that, okay, I just got opened, and I'm going to remember that I'm here in the file. I haven't read anything yet. And then if I say read a line, it'll go, oh, okay, so I read all this stuff, and okay, great. So now I'm not here anymore. I am here, ready to go. It remembers where it left off. So when you say read again, it will know where to pick up from. It's a little funny because it might act a little differently than you expect, but this is how we do it with this way of programming. If you really want to start over, the easiest thing to do is just, well, reopen the file. And it'll reset to go like, well, I haven't read anything yet from this open file. Because you just opened a new file. It's the same file. But as far as Python's concerned, it's a brand new file. So this might trip you up, but be warned, this is how it works. You may make this bug, you may forget this and then have a bug in the future. The point of right now is to remember, oh, I remember being told that something funny can happen here, what was it? And then you can it'll help you identify where the issue is. You might not remember what I'm telling you right now, but you might remember that I told you something about this funny case. So any questions about reading and how it just kind of, you read a single line and it remembers, pardon me, where it left off. So if you read again, it'll read the next, it'll continue reading from where it left off. No questions or anything? Okay, can you figure out how to reread from the file after you already read the full contents? Yeah, the simplest thing is to just start over. Open the file again. So note there are many more methods available to perform. Read line, there's read. Read reads the entire contents. Read lines reads a single line. Or read line reads a single line. Now there's an important thing I hadn't done yet. It's closing the file when you're done. When you're reading from a file, not that big of a deal, but it's very important that when you're done with the file, you close it. Very, very, very much so when you're writing two files. And I'll show you an example why later. Don't forget to put your mask on. So writing. Well, my other file, another file name, write. So, I'm just going to do this, delete. I'm just going to start over. I'm going to write this. my other file, I'm opening it, it's called another file name.txt, and I'm opening it in write mode. Notice now, does there exist a file currently called another file name.txt? No, it's not there. But it's fine, because if you are writing to it, it will create one for you. Let me prove that to you. I hit run. Now, sometimes it might take a moment. If I hit refresh, there. It's there. It's there. Now, what's in that file right now? Nothing. And if we open it, we see, well, there's nothing there. Right? Now, let's write to the file. My dot write. There, I ran that, I call this, and I open this file, but there's nothing there. See if I can, maybe I need to refresh it. No, nothing there. What's going on? Does that make any sense to you? I just said write hello world. Wouldn't it make sense for that to get written there?
Don't you need to close it first?
I need to close the file. Let's try that. Let's go down here. My other file dot close. There, okay, I ran it. Oh, there we go. After I closed the file, it was there. Now, I'm going to create another file called another file name. Refresh, it's right there. And right here, I'm going to say for I in range 1,000 are my other file dot write actually I'm going to write that. So I'm writing the current value of I and then a new line character because I want it to go to the next line. If I don't add a new line character, we'll just keep adding to one line. Yeah.
Okay, and when you had another file name, it printed at 11 for 1 line.
It was the return value. It returns, let's have a look at what it actually says. Returns the number of characters written. So when I said hello space world, HELLO space WORLD, that was 11 characters. So the function, it'll write to the file, but it returns like, hey, I wrote 11 things to the file. That's all. Interesting observation though. Okay, so my other file is open, and I'm going to run this loop. And I'm going to open up another file name. There's nothing there. Then I'm going to close the file. Do I have like a refresh? Here, let's close it and reopen it. There we go. Okay, now it's there, and it goes all the way to 1,000. So the reason we have to close the file is because of something called, we need to flush the buffer. So here's the problem. Now, what I'm about to explain is purely a consequence of how these machines work, okay? These machines are engineered a certain way and they work a certain way. What I'm about to tell you is not a fundamental truth of the universe, but it's just how these machines work. And what I mean by that is, if I give you the algorithm of a linear search, and I give you a collection of things, and you follow that algorithm, and I ask you, like, how do you prove that if it's in there, you'll find it, and if it's not, you return false? How do you prove that? And your answer is going to be like, I mean, what's there to prove? That's That's just how it works. Like if you follow, if I've got a stack of pages and I'm looking for my name on a page, if I look at each one and I find my name on the page, I found it. It's a silly question to say prove it, because you're like, but that's just a fundamental truth of the universe. It seems silly to state that because it's so obvious, but it is. So that algorithm works because that's just how things work in our universe. When I say this here, what I'm about to show you is this works this way because some engineer somewhere said so. Any I/O that you do is very slow. Your computers are really terrible at input-output, very slow at it. And I will show you an example of this by going down here, and I say for I in range 0 to 1,000,000, when I hit run, like look, I'm doing 10,000, we're like 1% of the way done. Like you can see how slow this is, right? It's taking a while. I'm gonna stop. I'm then just gonna say pass. I'm done. Pass is a keyword in Python that says like, shut up. I know you've got a for loop, and it means I need to have something indented, but if you write the word pass, it's like telling Python, shut up, I know, it's empty, deal with it. We can replace this with like a equals 7, just some arbitrary nonsense functionality, right? A equals 7. This assigns the value 7 to the variable a 1,000,000 times. Why? Because I needed to write something in there. Some basic computing, okay? This loop is going to run how many times? 1,000,000. In the previous example, when I was printing out I, how many times would that loop run? 1,000,000, because I set loop, to 1,000,000. But we saw after a couple moments, it was like 1% done. I'm going to do the same thing without any printing, with no output. Let's see how long it takes. And I'll know it's done when I see I'm done, because it's not in the loop. Oh, no. There. So your computer can work a hell of a lot faster than it can if it's constrained by printing things out, doing any input-output. So input and output is slow, because there's a lot of overhead involved. Okay, open the file, write this little piece of information to the file, update where that thing is. Okay, great. Next thing, add another thing. All of the overhead of opening and writing to the file is really slow. So instead, what we do is we have a buffer. It's like saying, okay, look, you want to write 1, 2, 3, 4, 5, 6, every number from 1 to 100 to that file. But if I were to write to that file 100 times, that's really slow. So instead what I'm going to do is I'm going to remember everything you want to write to the file, and then periodically I will flush the buffer by just writing what's in that thing I'm remembering I need to write to the file. So in our case, we saw that when I ran it 100 times, and I looked at the file, if I didn't close the file and I opened it, I didn't see anything. There was nothing in that file. So the computer didn't waste any time writing to the file. What it did was it remembered everything it wanted to write to the file, and then when I say close, it goes, okay, I will go do one write to the actual file. So instead of doing 100 small writes, it does one big write, which is way faster. So, long story short, close your files. If you forget everything I said about why it's important, and all you remember is, I just better make sure I close my files, yes, there, fine. Just close your files when you're done. Whether you're opening or whether you're reading or writing, just close them. It's a great habit. Let's see if Python, I'm curious, if Python has, a flush method that I don't really know, but I'm gonna take a wild guess. Flush right buffers, if applicable. So there we go. This says, okay, just what if you don't want to close the file yet, but you want to make damn sure everything that you wanted to write was written? Yeah, okay, you call flush. So close calls flush for you, but you can call flush independently as well, if you can. The takeaway from all this, close your files. Okay, write lines. Write lines works if you give it a list of things. Write will write to provided file. Write lines will write multiple lines to a text file based on a list of strings, whatever. Okay, great. This is just me telling you to do an activity of what I just explained. And then warning, close is important because it flushes the buffer. Great. Any questions about reading or writing to a text file? It's simple. I don't mean trivial. When I say simple, I don't mean trivial. I mean, there's not a lot of mechanics to it. So, but I mean, just because there isn't doesn't mean it makes sense to you like this yet. That's fine. There's a difference between easy and simple. I avoid using the word easy. So simple does not mean easy. It's simple, but there's a lot of fancy things you could do with it, and the only way to get better with it is to practice and see what you can do. So yeah, any last questions about reading and writing from a text file? Okay, the next thing are CSVs. CSVs are a very common file formatting type. Now, some people are bad with them, but okay, long story short, CSV, comma separated values. Sometimes you have data that, it's textual data, it's a text file really, but you know, the data is kind of like in a table. It's like tabular data. Think of the Starbucks one, okay? The data I gave you, each row was a Starbucks location, right? And each column had different information about the Starbucks location, right? You had the name, the latitude, the longitude, right? So it's tabular data. And on assignment 1, did anyone download the file and open it, and then notice that it got opened in Excel? Did anyone notice that? Yeah, so I didn't give you an Excel file. I gave you a comma separated value file. And I will prove this to you by going to assignment 1. And showing you density Starbucks. Okay, I'm downloading the Starbucks file. Show folder. So here, it's a CSV. I'm going to open this file in just a text editor. And this is what you see. Oh, I guess it's not even, it only had 2 columns. It had latitudes and longitudes. You open this up, all you see is a number, comma number, a number, comma number, a number, comma number. Each row is an individual Starbucks location, and the columns have different features about that location. It's very tabular. I could give this to you in a table, and you would be very happy with it. And because everyone knows CSVs are for tabular data, if I go to open this, it's going to want to open it in something like Excel. This isn't Excel, but it's Excel. It's a spreadsheet thing. It's taking a little while to load up. Yeah. Open. And you open it. And when you go to open it, it will just, here. It just shows it to you in Excel because it's kind of like a table, right? It's just being nice to you. So I didn't give you an Excel file, but Excel knew to open up CSV files because it's a nice way to visualize them. But ultimately, at the end of the day, it's just a text file, but the convention is the commas and rows have important formatting. Commas differentiate columns, and new lines differentiate the rows. That's all. It's really just a text file, but when you see .csv, it tells you and the computer that, well, it's a text file, but really it's following this CSV convention of rows and columns. Questions about the spirit of CSVs? Now, if you're ever programming in the future and you're like, I'm not going to use commas, I'm going to use tabs. Don't. You're bad. I'm not going to use commas. I'm going to use some arbitrary amount of white space. Terrible idea. Just follow the convention. If you're in a situation where, well, what if the information in those cells contain commas? Like, what if one of the entries is like a string, but there's commas in there? Okay, there's things you can do in that situation. Maybe commas are problematic, but just comma separated value. Don't start adding a bunch of spaces and being like, oh, it's a CSV. No, it's not. It's a white space separated file now. That's just a me rant. All right. Don't go invent new conventions if there's a good one that already exists. All right, CSVs. They are fantastic when you have tabular data. Every computer scientist programmer out there loves CSVs. So this would be a great example. Like if I wanted to keep track of the name, height, weight, and IQ of individuals, great. A CSV would be perfect. Right? I could have like their name, their height, their weight, and their IQ. This particular example here would be a CSV file that includes like a header line, a line that kind of describes what each column is. But you don't need that, right? Like in assignment 1, I didn't have one that says latitude, longitude. Whatever, it's just the format it is. But sometimes you will see them like that. But the point here is, it's tabular data. And we can think of it as a table like this, right? Do you see? It's the same information. That's the spirit of what it is. Python, now, it would be pretty easy. I'm going to take this data right here. I'm going to put it into temp. Okay, here's what we're going to do. We're going to go close that, delete, 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 delete. All right, whatever, okay. My file equals open in read mode, okay? Now, I could very easily parse this text file with the spirit of CSV fairly easily. What I can do is I can write like, okay, my file dot read line, okay, then I can say, okay, the equals the line dot split, but now I'm not splitting on white space, I'm splitting on commas, and then I can print there, right? Like, it's fine. I can read the line, I can say split on the commas, and then I get the list of things right here. Great. But Python has a library called the CSV library that makes reading CSVs just a little bit, it just simplifies the process just a little bit. I open the file, so import CSV. I'm going to say csv.reader. Okay, great. So I just nested the open call. I could have like put it here. I opened the file and then I passed the file to a CSV reader. I just did it in one shot on one bigger line of code here, whatever. I'm opening it as a CSV reader. Then I can very easily just say like, okay, for row in my file, print row. There, it's just there. So it's just simplifying the process a little bit of how we could read a CSV. It just, slightly better. It'll save you literally minutes. That's it. right? So the CSV reader and CSV writer exists for reading and writing to CSVs, slightly easier than having to do your own string formatting and string parsing. Because string formatting and string parsing is kind of annoying. Who here agrees with that statement because you've used CATS? String parsing is a fancy way of saying, okay, look, this input is coming in as a string, and it's going to look like this, but really what I want to do is extract the 3 integers from that string, and then I can make use of them. Parsing is the process of taking the input and turning it into what you actually need to use, right? So caddis is always really annoying with that, right? Read the input, split it, convert it to an integer, right? It's kind of annoying. Well, the CSV reader kind of does a job to make that slightly less annoying. That's all. Okay, there we go. CSV. Okay, so we are going to run out of time. And here's an example of writing. Okay, great. So I am going to highly recommend, strongly, strongly, strongly recommend you do this activity. You do these 2 activities when you get the time. Okay, you know what? We'll do the first activity together. We have time for that. So I'm going to download the CSV file, airports.csv, show in folder. Okay, I'm going to go to my Colab. Let's delete, start fresh, delete folder. Yep. What? Okay, fine. New notebook. You're obliterated. So I downloaded the airports.csv, and we're going to open it, sure, with the Excel type thing. Open. So what do we have here? Well, it's a CSV that only has 2 columns. The first column is going to be airport code, and the second column is going to be the name of the airport. Uh-oh. Was that an alarm?
It's not a lot.
It's 12 o'clock. Ah. So like, for example, we see at the bottom I've tacked on Halifax. YHZ is the Halifax airport's code. That's all this is. And what I want to do right now is just load in the data and have it into like a list of lists here. So what I'll do is I'll have each row will be the list like YHZ, comma, Halifax Stanfield International Airport, Halifax. And then I will have just a lot of lists containing just all of the rows of information. So that's the goal. So first things first, I gotta upload the files. So upload, downloads, airport.csv. Yeah. Okay. So I'm def load data, and we'll have it like file name, and it gives me back a list. Load airport data. So the idea here is I can call this function and give the function the file name, and then it will go and load up that data and return it in like the list. So I can say, well, first I know I need to like import CSV. Okay. So I will say my reader airports.csv. Oops, I'm doing this wrong. Airport and then open airport CSV and read mode. There. So this line right here, actually I don't want to just call it airport CSV. I want to be able to just pass whatever the parameter given to the load airport data function is. Great. Cool. Questions about what I've done so far? All I've done is I'm starting to define a function that takes a name, a string, the string will be the file name, and then the first line of that function is, okay, go open up the file with the specified name that was given to this function as a parameter. That's all. So it's like, I'm the function calling you and you're the CSV reader thing. So it's like, oh, okay, you gave me a string. Here, just go open this file. That's the idea. I'm just passing it on right to you. So there. Now I've got my CSV reader. Now, here's what I'm going to do. I'm going to say, okay, airport, start as an empty list, and then each time through the list, I'm going to read from the CSV file, read the row, and then just append that row to my list. Remember, append for a list just means keep tacking on to the end. Empty list, if you append to an empty list, well, that thing that you append will suddenly be at the beginning of the list. And then if you append again, well, you've added another thing to the end. You append again, you add another thing to end, and so on and so on and so on. We can append forever. So I'll say for row in, now remember, row, again, it's just an arbitrary variable name. I'm just calling it row because, we've got columns and rows. So for each row in the CSV thing, for each row in my file, I'm going to take that row. So I'm going to say airports.append row. Okay? And then, now, interestingly enough here, I know I ranted about closing your files. I can't close this file. I can't, because it's in the CSV reader thing. Not the end of the world, because reading from a file is a little nicer. But maybe what I should do is open file name R, and then my CSV file. I'll rename this my CSV file. Okay, now I can say my file.close. So now I can properly close it because I actually have reference to the actual file. And then when I'm done, I will return airports. So there we define it, and then list of airports equals load airport data airports.csv. Okay, great. And now print list of airports. There we go. Now, we see it's a list of lists. I mean, this is the outside list, and then inside of it, it's another list. So I can index, well, what is list of airports at index 0? Whoops. Well, that's that heading line. That's the line at the beginning. Index 1 is Allentown, Bethlehem, Easton International. Index 2, Albuquerque International. So it's in order. It's just I have a list of lists, right? Because we can see this is clearly a list of 2 strings. So there we go. We've got our rows, and then each row is a list, comma separated, kind of specifying the 2 columns there. Someone said something, what?
No, I was just saying where Albuquerque was.
What about Albuquerque?
It's from Breaking Bad.
Yeah, but what about Albuquerque though?
It's in New Mexico.
That's correct. Okay. I'm not sure what you were getting at though.
No,
Oh, I eavesdropped. I see. All right. So there. Now we've got the load Starbucks. What is happening? Load Starbucks data. Now, maybe we will pick up here tomorrow. I think this would be a good idea to pick up here tomorrow. Get name from code. So the idea is I want to write a function that I can give it this list of lists and also a specific airport code. And I want you to return the full name. So if I gave you ABQ, I wanted to say Albuquerque, blah, 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 blah. Cool. All right. I'll see you later.